Welcome to my projectbazaar.com. Let us discuss about the event to sync spectrum aware clustering in mobile cognitive radio sensor networks. Let us discuss about the abstract of the product. Cognitive radio sensor networks are event-based systems such that sensor node detect events and the event readings of the sensors are collaboratively conveyed in a multi-hop manner through backend channels from event region to a sync. Hence, the event to communication and a dynamic radio environment requires a coordination scheme in CRNs. In this paper, we propose a spectrum-aware clustering protocol to address the event to sync communication coordination issue in mobile coordinated network. Our clustering schemes consist of two phases. The first phase is the determination of nodes eligible for the clustering, and the second phase is to form the clusters among those nodes according to vacuum spectrum bands. Clusters are temporary and they are not preserved after the end of the events. Furthermore, we find average reclustering probability, expected cluster coverage area, and find maximum event of generation frequency for energy efficient operation of our protocol. We study performance of our protocol in terms of control and data packet exchange, time steps required for clustering, connectivity of clusters, energy consumed for clustering, and reclustering ratio due to the mobility. Performance comparison simulation shows that our algorithm has better performance in terms of connectivity and energy consumption. Let us discuss about the flow diagram of the product. Initially, the state is nodes and base station deployment. That is, in this proposed method, primary users utilize the license band without any restrictions. But cognitive radio nodes are secondary users which can access license channel if there is no primary user activity. It can move according to the random waypoint mobility model. The nodes form a graph denoted by G, and where V is a set of nodes and E is a set of each node connecting the nodes. Two neighboring cognitive nodes are connected if they common channel. They are M non-overlapping orthogonal channels having unique IDs. The nodes can detect backend spectrum bands by wideband spectrum sensing. The next block is spectrum-aware clustering. In this spectrum-aware clustering is one type of algorithm. So to use this algorithm to determine the eligible nodes and to form the cluster. So this is the algorithm process. Two steps for managing eligibility and mobility of the nodes during an event. The next one is the cluster side selection. The motivation of clustering in sensor network is to create organizational structures and to manage distributed wireless sensor networks in a structured way. The dynamic radio environment intensifies the need for a clustering scheme to coordinate the communication in type of coordinated radio system. In this work, we group the eligible nodes in the event to sync coordinator according to the spectrum availability while maintaining inter-cluster and inter-cluster communication. Only the nodes that are appointed as an eligible form of clusters. The clusters are not maintained in the network if the event detecting nodes do not further sample the events. Cluster heads are the local coordinates in the cluster form. They perform data aggregation, manage the change of ideal spectrum bands in the clusters, and manage the mobility of the nodes. These also receive the event reports from the cluster members that are very closer to the. And then the block is the determine the cluster members. So in the determining the cluster members subdivided into 2 parts. One is a dominating set and another one is a convergence. So the dominating set, the nodes are according to the dominating, and the convergence is responsible for the convergence of the people. Next of all, they increase the energy efficiency. Finally, we achieve the energy efficiency. That is S. The performance evaluation will be calculated. That is no. Again, the process will be continued while determining the eligible nodes of the. So in the performance evaluation, we study the performance of our protocol in terms of control and data packet exchange, time step required for clustering, connectivity of clusters, energy consumed for clustering, and reclustering ratio due to the mobility. So the performance comparison simulation shows that our algorithm has better performance in compared to our existing work, that is in terms of connectivity and the energy consumptions. So these are the description of the flow diagram. Here we discuss about the running procedure for the product. Select the main file for executing the product. So now by executing the file, many outputs are displayed. So these all the outputs are related to our flow diagram. So this is the figure 1. The figure 1, this is the system model. So these are green colors are the cluster nodes. So this is the base station. So this is a base station and these are the cluster nodes of the figure. So this is the system model of the So in this figure, the cluster formation in round 1. Up to 5 rounds we form the cluster formation. So these dark circles are denoted the cluster heads. Now balancing the nodes or this is our cluster nodes. So these are the cluster heads. This one and this one and this one, this one, this one. So the dark circles around the cluster. So that is our cluster heads. And remaining part of the nodes are very denser nodes. So similarly, the cluster formation in round 1 and round 2 and round 4 and round 5. So up to 5 round, the cluster formation is formed during to the cluster headers. So this graph shows the data and control packet exchange for different cases without the mobility. So the blue indicates the control packets and the brown indicates the data packets. So the circle of the line is the total packet size will multiply with 2, and the square is denoting the multiply with the 4. So these are the number of packets and these are the number of cases. So this is the data and control packet exchange with the different schemes without the mobility of the process. Similarly, this is the data and control packet exchange for different cases with mobility. So the same process. The blue is indicates the control packets and brown is indicates the data packets. Totally the 8 cases are defined this. So the fishes of a number of packets. This are the mobility of the graph with mobility of the particle. So this graph shows the time steps required for clustering versus DES, that is distance with respect to small r. So the small r denotes the transmission range in meters. So these are the existing system. Our system was a MESES, that is mobile environment event to sync allocation method. So this is our proposed method. These are our existing method. So our proposed method is compared to very low compared to all the existing method. So these are the time step for clustering. Similarly, the same graph, time step required for clustering versus distance with respect to caps r. Here the caps r is denoted as the event radius in meters. So the black is denoted our proposed work and other all our existing work. So the black is very low compared to all the existing system. So our radius is very low compared to all the existing system. This is the time step of clustering. This is the distance. So this graph is shown as with respect to the same procedure. This graph also shows the negativity versus distance with respect to smaller. So the blacks denotes our proposed method and all the colors is just in the existing method. So this is the connectivity, this is distance. So in this graph shows the recluster cluster heads. So this is the ratio of recluster cluster heads and this is on the time steps. The blue and square that is indicates our proposed method and other are the existing method. So the ratio of the recluster cluster heads is a time for the different type of mu. So this is our proposed method. Our proposed method will be high compared to all our existing method. So similarly for scene, this is also the recluster cluster heads versus times up for different weights. So W5 is equal to 0, W5 equal to 0.05 and W5 equal to 0.1. So these are the different weights calculated in the recluster cluster heads. So the ratio of the recluster cluster heads, this is the time step. So these are the running procedure of the product. Thank you for listening this video.